So you are most welcome for our lesson today, and we are going to look at probability. And in our lesson today, we are going to concentrate on two things, what we call how to determine probabilities from experiments and real life data, but also we must be in position to differentiate between what we call theoretical and what we call experimental probabilities. That is going to be our major area, what we call theoretical and what we call experimental probabilities. I want before we dive into this, who can give us some highlight on what you think theoretical and experimental probabilities are, or what you understand by those two words? Feel free to raise up your hand and you just share with us what you think experimental and what? And theoretical. The difference between those two. Any that may have an idea, you can share with us. Okay. I'm saying Amara. Yes, Amara.
Teacher, my idea is, I would say that theoretical. Theoretical means that it can be an idea or a thought that is not either tested but is created or made by somebody. Then experimental is you're trying to see or you're trying to test whether if I do this, if like, let me say, if I get lemon in water, how will it taste? That's what experimental means in theoretical, in my idea.
Okay, thank you. Okay, thank you. There is an idea. Yes, Rona?
I think theoretical probability is like something is likely to occur or it's not likely to occur. For experimental probability, I think it's an I'm not sure there, but for theoretically, I think this probability is likely to occur or not.
Okay. Okay. Then lastly, Adong. Thank you, Rona. Adong.
I think your experimental probability is based on an actual experiment or observation.
Okay. 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 Thank you, Adong. So in the chat, Patricia is saying experimental is practical. Theoretical is stated without practice, just thinking. Very good. Joel Asimo is saying theoretical is whereby we use formulae to find out, while experimental, we do it in real life. Very good. Yeah. So those are the ideas, and those are things we have said is correct. I'm going to just give you an example. Is that take an example? Yesterday, I got my coin. I got here some coins here I had. And I said, let me toss the coin 2 times. I toss it 2 times. So when I toss it 2 times, I had my coin, I tossed it 2 times, and I wanted to see what do I get. In fact, so you'll note that here, theoretically, like when you toss 2 coins, let me say I'm tossing 2 coins simultaneously. Theoretically, we have to get, we know that we shall get head, tail, 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 maybe head, tail, and head, head. That is theoretically. But when I did it in practice, I get my coins, I toss them. I want to let you know that the things I was getting, I got head, 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 or tail, something like that. So theoretically is different from what we call experiment. Experimental, you do it practically, and you do it in a number of times. For something, for these theoretical ones to come into play, it means that you have to do this experiment for very many times in order for you to get what is in practice. Take an example. Some of you look at those numbers we do in physics, maybe biology and what. Theoretically, you'll find out that maybe for a glass block, they are telling you that the refractive index is 1.5. But when you go in the lab, for you to get maybe 1.3, 1.4, something like that. So what does it mean? That for you to obtain the 1.5, you have to do it quite a number of times in order for you to be able to do it. So for experimental, we are looking at those we make observations. The results we write are as a result of making an observation. Sometimes even you can use simulations. So with experiments, we have to make observation. We do it practically. Like yesterday, I was telling you to toss a coin. So by tossing a coin practically, it means that you are doing an experimental probability. But if you do it using the knowledge theoretically, like all the numbers we have been doing in the past exercise that we have started with today, most of them were theoretical work, but not experimental. Because when you go into the field, you'll find that actually when you toss a coin, when you toss two coins, you may not end up getting a head, tail, 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 head, tail, head, head. No, you may find yourself even getting tail, tail only. Even you can end up with the experiment when you toss it 2 times when you are getting something different. So kindly let me know, have we picked something, the difference between theoretical and experimental? Because that is the major aim for today's lesson. So I want to look through the chat. Okay, very good, very good. Aha. Okay, that is very good. Okay, now we can start with some work. So you write about it briefly, but you can write, feel free to write in your own words. Don't use my words. Or don't use these words here. So you write about experimental probability. Okay, I think members are fin. Okay, I hope. Okay, people have finished. So we are going to start with the first one. So first write that.
In progress.
Okay, let me hope members are finished to write. Okay. Okay, not yet. Okay, let's finish. Okay, members have finished. Okay, now we have Solange tossed a cylinder 24 times. Now, when it comes to experimental probabilities, we always do it quite a number of times. So you don't do it once, twice, thrice, four times, 5 times, and then you think you have done an experiment. For scientific things, if you want to make a good conclusion, you need to do quite a number of experiments such that you can come up with a good conclusion. Take an example. If you are testing out you are testing out a vaccine for any disease or for any virus, you cannot base your conclusion on just 3-4 people you have tested and they became okay. No, you need to do it on about 1,000 even plus, such that you see whether the result you are getting after the person has been given that vaccine is the same with other people. So you do quite a big sample space such that you can come up with a conclusion. And I think if those who are following during the COVID-19, the vaccine that was developed in Uganda, they had to use a big sample space, but they had to first get your consent. They ask you, we want to test. Even they had to pay you. They had to give you some money. They inject you, and then they keep monitoring the result. So for experiments, we always do it on a large scale. We always do it quite a number of times. So they are telling us that Solange tossed a cylinder 24 times and recorded whether it landed on one of its base or its side. You know that a cylinder, you can just imagine something like this, something like that, something cylindrical, something like that. So this is like let me use down. This is like the base and this is the side. So the cylinder could land like this or it could land like this in this format, like that. So this is like the sideways, and this is like the base. Now they're asking you, based on Solange's experiment, which way is the cylinder more likely to land? So what could be your response? You can raise up the hand and you share with us what you think. Okay. Yes, Paul.
I think the cylinder is most likely to land on its side.
What have you based on, Paul? Yes, that is correct.
Based on its frequency.
Based on the frequency. Very good. But now, from today onwards, frequency alone may not be able, like you can't use frequency alone to be able to give a conclusion. So we have to go further ahead and look at the percentage. You look at the percentage and then we do a good conclusion. So here we are going to apply our knowledge of probability and then we conclude in a probability way. So what are we going to do? We are going to say that the probability of the base appearing is equal to the number of times, allow me to abbreviate, but for you don't, the number of times the event occurs out of the total number of trials. Now, when you check the first one, here I'm looking at the base. Now, when you look here at the base, you are noticing these are 5, these are 5, this is 11. So you are noticing that it is 11. And the total number of trials Solange did they were 24. So it is 11 out of 24. Then when I go on and I look at when it was on its side, on the sideways, you are not seeing that we had about 13 out of the 24. Now, when you look at the fractions and you are telling someone, you are giving someone a conclusion, someone may not be able to understand clearly whether it is 11 out of 24 or 13 out of 24. Imagine you are telling someone for an easy to understand language. Now, let me know through the chat which are, because I've told that we can write our fractions in 3 ways. So through the chat, can you let me know on percentage, decimals, and fractions, which one do you think will be the best one to use for us to be able to make a good conclusion? Mark is saying percentage. Percentage, very good. Percentage would be the best. Okay, very good. So here I'm going to go on and I say this is 11 out of 24 times 100. So when you place your calc, I think you'll get something like 45.83%. The same thing here will happen. This is 13 out of 24 times 100. And this will give you 54.160%. That's why whenever you want to communication, you must be in position to make someone understand what you are saying. Otherwise, when they don't understand, it means you have not communicated. So for us here to communicate, percentages will bring out the idea very well. So now when you reach here, now you can compare and say that since 45.83% is less than 54, sorry. Okay, it is okay. It's less than 54.16%. It is more likely that the cylinder will land on its side. I don't know that one is okay. Are we together on that? Okay, I'm saying that when we are concluding now, here at the end, I look at the percentages. That at the base, I have 45. At the side, I have 54. Then you compare which one is bigger than the other. Then you notice that 45 is smaller than 54. Then this means that the one of 54, it is the one that you are going to base on to make your conclusion. You see that since 45 is less than 54, therefore, it is more likely that the cylinder will land on its side, like that. So it depends on which side has the bigger percentage. But when you have made your calculations, okay, hope that is very, very fine. Okay, I think we are good to continue. Members, are we good to continue? Okay, we are good. I want to give you one to try out. Okay, I have that one. So for experimental probabilities, you write what you have obtained. So meaning that when you carry it out, you cannot have the same answer. Even when you go in the laboratories, and you do, it is very hard for all of you to get the same answer unless you have tried the experiment about 10 times, even more, that you can come up with almost the same answer. But we don't expect the same answer whenever you go in for experiment. Whenever everyone goes on, But here I've used Solomon that spanned the spinner several times and recorded the result. So when another person, let me say Hannah, goes there, she'll get other results. When Audrey goes there, she'll get another result. When Angel goes there, another result. Mujuni, another result. Joyce, another result. So you'll find that everyone will be getting something different, not the same. So it depends on what you have done. Okay, now I'm going to be choosing okay. Joel. Joyce.
Yeah.
Yes, what do you have for the now part
The
one?
correction was the part I had to rejoin.
Oh, okay. Virginia.
Yes, teacher.
Yes, what do you have?
Teacher, I'm still working on it.
But first, share with us what you are doing now. Tanya.
Yes, teacher.
Yes, Tanya, what are you doing? Can you share with us?
So I'm still working on it, solving internet problems.
Okay. Okay. Bogele, Joshua.
Teacher, as of me, I've added up the total, which is red.
Okay. The total.
I've got red,
Uh-huh.
then I added plus yellow,
Mm-hmm.
plus green,
Okay.
plus the 7. So the
Okay.
question is the 7 for orange. So the question is asking about the probability of the spinner landing on black.
Mm.
So the frequency of black is 3, so we'll exclude it. We'll put it
Okay.
on the side. So we'll add up these 4 numbers, which will give us 17.
Okay. Okay. Now, the first question I'm going to ask you, Yeah. Now, always, it is the first thing you have to do is to find out how many times did Solomon try out this experiment? So, first share with us, how many times did he try out the experiment, Joshua?
We tried it out 20 times.
Aha. That is always the first thing, the total number of trials, eh? Is that fine? So the total number of trials, which I can call maybe T, is equal to 20 times. Very good. Now, let us look for the event that it landed on black. So what is the event that it landed on black?
3.
It is 3. And how are we going now to get our probability that it landed on black?
It's going to be 3 out of 20.
3 out of 20. Is it what you had done?
Yes?
Is it what you did?
Yes, teacher.
Okay, perfect. I don't know whether members were on the same page. Members, is that okay? Anyone that is lost that needs some support? Okay, it seems we are on the same page. Yeah. So always for any experiment, first find out how many times did this person try to do the spinning? How many times were they? That is the very first step you have to do. Then from there, the rest of the things can come in. Otherwise, if you don't know the number of times, then you cannot be able to know the chances of him having hit a black or yellow or green or yeah. So that one is really very important. Then the probability that the spinner will land on red, I've seen some answers already in the chat. Land on red. So people have already put the answer. Okay, on red. I don't. Victoria is saying red is this. Okay. That is very good. Okay, red is 25. 25 joy. Okay. That is power 25. 0.25 for red. Okay. 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 Shekaina, how did you get your answer?
So I just divided 5 by 20 and I got 0.5.
Okay.
That
5.
event, which is 5, out
Mhm.
of the total number, which is 20.
Okay, you ended up with
0.5, 0.25.
0.25. Okay, that is good. Okay, then the last one, based on the experiment, which color will the spinner most likely to land on? Okay, I'm seeing a hand up. Yes, Virginia?
Orange,
Orange, and why?
because it happens to have landed the most times. So there's a chance it would land there. Okay, again. I don't know how to explain it.
Okay. Can you now include in more reasoning with the real calculations?
According to my calculations, the probability is 7 out of 20, which is 0.35. Yeah, which happens to be the color where the spinning has landed the most. So maybe to keep landing there again. I don't know.
Okay. Will Virginia, will a layman understand 0.35?
No.
Okay. So which answer would you use?
35%.
35%. Okay, that is good. Okay, thank you. Okay. I think we are good to continue, members. Let me know through the chat. Are we good to continue now? Okay, I think we are good to continue. Okay, now, okay. Yes, Fefa.
There is someone, she's called Joy Patience. She says she's not on the same page with us.
She's not Joyce. It's called Joyce.
Joy Patience.
Joy. Okay. Joy Patience, kindly unmute. Yes, Joy.
Yes, I kind of came in late. I've not understood the thing of experimental probability.
Experimental probability. Okay. Let me ask Favor. Favor, can you first explain to us what you have understood?
What I've understood by experimental probability is the thing, like, let me say, if it is a coin, if we toss it, that process of doing it practically means we are experimenting, and it is supposed to be done a number of times so that we can get a number of results.
Okay. Thank you. Ithola.
Okay. I understood the thing, but I wanted to ask. The first part when the question was being attempted the first time, finding the total, the frequency for black was excluded. Yeah. Why?
Really?
Yeah, this first one.
I'm there. It was 5. 5 is there. 3 is
Yeah.
there. 2 is here. 3 is here.
Oh,
And
sorry.
7 is here. Okay. 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 Hope Ethola, it is fine. Okay. Now, Joy, like they have already told us, Favor, she has already shared that when it comes to experimental probabilities, these we do them practically. We do it practically and for a number of times. So the first important thing you need to know is that when it comes to these experimental probabilities, it is always very important to first find out how many times has the experiment been carried out. We have said that you can't carry on something 1, 2 times and 3, and then you conclude from there. That one cannot give you or yield a good result. So it is always a good practice to try out something for very many times such that you can be able to conclude. So the first thing always you have to do is that first obtain what is the total number of times an experiment has been carried out. After getting the total number, then you can go on and find out the possible the events, or what we call the single outcome for that particular experiment. But please, I think here you'll be able to pick. So let me pick Anne Mujun. Audrey, you are the next. And do for Anne.
Yes, please, teacher.
Yes, go take us through the first steps, and you find for us at least A.
Okay. Find letter A. What I first did was I first said number of, in brackets A, close bracket, number of total time event occurs out of total number of spins. So I
Okay.
said 14 out of 30 because that's the total frequency.
Okay. So the total you got 14 plus 7 plus 11 plus 8, you got
30.
30. Okay.
So
Then
since so since A is 14, I just got 14 out of 30.
Okay, good. Then they told you in the simplest form, what did you have?
So in the simplest form, I first, since to me, I saw that both of the numbers were divisible by 2.
And can you first add again? Can you first add again your frequency, and we see?
Okay. Oh yeah, it's 40. Sorry.
It is 40. Okay.
So 14 out of 40. So they wanted it in its simplest form. So I saw that both of the numbers are still divisible by 2. So 14 divided by 2 is 7, and 40 divided by 2 is 20. So 7 out of 20.
Out of 20. Good. As the decimal?
As a decimal, we just get 7 divided by 20 to give us 0.35.
0.35. Okay. As a percentage?
And then we get that 0.35 times 100% to give us 35%.
Okay. Thank you.
Okay.
Okay. Audrey? Part B? Okay. Jonah?
Yes, good morning, teacher.
Yes, good morning.
Since we have already obtained the total trials, we are going to just say 7 out of 40.
7 out of 40. Mm-hmm.
And when I'm to check that, it cannot be simplified.
Okay.
So, as a decimal, it is 0.175.
Okay.
Then as a percentage, you just multiply by 100 and we get 17.5%.
17.5%. Okay. Thank you. I think the rest the rest of the numbers we can go on. Then rest of the parts we can go on and complete part C and D. Okay. But maybe people just need to confirm that for some of you may not have calculators. So here for part C, I expect you to have 0.275 and your percentage will be 275 point that, something like that. Then for D, I expect you to have 0.2. So this percentage is 20% and the reduced fraction is 1 out of 5. So in case you have those ones, then it is very good. Yes, Karen. Yeah, Karen, you're on track. Karen, that is very good. Karen? Okay. 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 Yeah. So, okay, you're going to allow me. Okay, this one is going to be your exercise. Allow me now to leave you with some numbers, as this one is going to be your part of your exercise. You just take a screenshot, but good enough, I'll be sharing the work in your group. That is one. This is going to be your second exercise. Don't worry, I'm going to share the numbers that you try out. This one is going to be your third number for trying out. Yes, about experimental probabilities. So we do them the same way we have done the other ones. Okay, then I'm also going to give you this as one of your assignments to carry on this experiment. But still, I'm going to post it in the, okay, people want me to go back. Okay, let me first go back. Okay, first take a screenshot. I know some of you may not be on WhatsApp. So that is one. Okay, people have finished. That is the second one. Oh, there's one I've jumped. This is the third one. Okay. Then this assignment still, I want you to try it practically. You can here feel free to use what you have. You can either use a soda or water bottle top in case you have. In case you don't have, you can use coins. Feel free for you to write, and then you do for me this kind of experiment. You can you can put the tally. You can even add a column whereby you have a tally. Let me say you can add a line here and say here I will put the tally and then I will get the frequency. Okay, so we are going to do it 20 times. And then I think you can send me your work after doing it on WhatsApp. Then I will share with the groups to see what different members have obtained from their experiments. Okay, and then this will be the tasks that we shall be doing. Okay, now allow me to go through now what we call I'm going to now concentrate on what you call theoretical probability. But when you look at my screen, I'm trying to compare and show you what we call experimental probability and what we call the theoretical probability. So we are like we have said earlier on that when it comes to experimental, we do it and we repeat it quite a number of times while observing. When it comes to theoretical one, here we always base on the expected outcomes, what we think theoretically. So that is the theoretical one. So we are going to deal now with theoretical one and not experimental probability. Now we are going to deal into what we call theoretical probabilities. Okay, so I think we can start on this under theoretical probabilities. And this is going to be our first number. They are telling us that we have a bag that contains 10 red marbles, 8 blue marbles. So you have the red ones, like these are the red ones. You have the blue ones, these are the blue ones. And you have the yellow ones. These are our yellow marbles. Now they're asking you that find the theoretical probability of getting a blue marble. Now, always, whenever we come to probabilities, the first thing always you have to do is, please go on and first find out the total number. How many marbles were you having in your bag? That this was our bag. Inside here, they have told you already, you had the red ones, you had the black ones, you had the white. So first ask yourself, in the bag, this is our bag. How many red ones do we have? Then you'll be able to do the number very well. That these were the red, they told me they were 10, so I can, yes, they were 10. Then they told me they had also the blue ones, which were 8, so those are the blue ones, but also they had the yellow ones. Now, the first thing always you have to do is find out how many do you have in total. So members, how many have you counted in total? 20, and it's telling me 20. Okay, so that means that according to what I've seen, Anne has told us that there are 20 marbles. Now, in order for us to get the probability of getting a blue, shall I say that the probability of getting a blue is equal to the number of invent out of the number of the total, or what we call the sample space. Now, you ask yourself, how many blues do we have inside? So remember, the invent will have 80 blues, the single outcome we are interested in. So mean that to get the blue, I'll have my 8 divided by the total, which is 20. So if you want here, please go on and reduce. So when you say 8 divided by 20, you'll end up by 2 by 2, you can reduce, which gives you 2 out of 5. In case maybe you want it in percentage, then you go on and convert it into percentage, that this is going to be at 40%. Yes, in case it is in decimal, you can as well write it in decimal as 0.4. Yeah. Members, is that fine for theoretical? Is it? Okay. Okay. Fine. Okay. So let's write quickly. I want us to do one more. One more. Okay, it seems people have finished. Okay, we can go to another one. Okay, you can first write this question. And those who can fill in those spaces, just raise your hand and you fill for us one space in case you can. There's something missing there. This is 2, this is 3. Yeah. In case you can, feel free to raise your hand and then you tell us what you think. Joy, Patience,
Yes, sir.
are you picking something or no?
I'm picking something.
Okay. Okay, Favor?
For me, I would love to do 2, the factors of 100.
So what are you feeding in there?
We have 1,
Uh-huh.
2, 4, 5,
Uh-huh.
20,
Uh-huh.
25,
Uh-huh.
150. Then, yeah. So in
Oh.
total,
Uh-huh.
1, 2, 3, 4, 5, 6, 7, 8.
8
Yes.
factors of 100. You have missed out some. You repeat. We'll go to repeat again.
1,
Uh-huh.
100,
Uh-huh.
250,
Uh-huh.
425,
Uh-huh.
520. Oh, 10, 10.
10, eh?
Yes.
So how many? I'm not putting that 10 because we shall have repeated it.
9.
9. Okay, thank you. That is okay. So that's what was missing there. Gift. Gift.
I wanted to do part A.
Part A. The
So,
prime numbers?
yes,
Okay.
of the first 100 positive integers, you're having 25 prime numbers.
Very good. We have 25 prime numbers. Okay, that is very good. Then the last one, number 3. Number 3.
Yeah, I don't know. But
Okay.
for part A, probability is 75 out of 100.
Out of 100. Okay, good. Good. That is correct. Okay. Okay. Now here, for this one, I can help you. These ones are 68. Now, when you look here, they asked us to enter this information into a Venn diagram. Now, we are going to have our Venn diagram. This is going to be our Venn diagram. And in our Venn diagram, we have 2 things. When you look here, we are looking at 100 positive integers. We are looking for prime and factors of 100. So I'm going to come here and I say, here I'll have my prime. Here I'm going to say factors of 100. Then I ask myself, do I know numbers that are both prime and factors of 100? That probably I'm not yet sure about them. So there I'm going to put X. But I know that my prime numbers are equal to 25 and factors of 109. So to get here, we shall say 25 minus X. To get here, I will say 9 minus X. Then they have told us that 60 are neither prime nor factors of 100. So I'll come and I put them outside here. Now, may I ask members, using your knowledge of set theory. Who wants to take us through using the knowledge of set theory? Okay. Yes, Favor.
25 minus x plus
25.
x
Mhm.
plus 9 minus x plus 68 equals to 100.
Okay.
So it will be negative x plus 25
Mhm.
plus 9 plus 68 equals to 100. Negative x plus, someone can hope add 68 plus 25 plus 9. Yes, it's 102 plus 102 is equal to 100. So we subtract 102 from both sides.
Okay.
Negative x is equal to negative 2. We divide both sides by negative 1. And our x will be 2.
Yeah, thank you. That is
So,
correct. That is very correct. Members, hope we have that. Okay, Favor, don't go off. Just let us conclude on this. Kindly tell us. Now, in the prime, what shall we have? 25 minus 2, what do we have? Okay.
we have 23.
23. Okay, then here we have 2. Then what about here?
7.
We have 7. Very good. Okay. Now, the first question wanted us that what is the probability that a number is not prime? Now, a number that is not prime, I'm going to shade. The first thing you need to know, when you look at those sets, where are the prime numbers? Here is where we have our prime numbers. Now, when they ask those that are not prime, it means that anything outside that Venn diagram is not going to be prime. So meaning that those that are not prime, we are going to have here what we have here and what we have outside. So I'm going to come here and I say those that are not prime, we are going to have our invent. Now that is the invent, the number of elements within the invent. That means we shall have the 7 and we shall have the 68, which will give us 75. So now to get the probability of something not prime, it means that we are going to get our invent, which is now 75, divided by the total number, which is 100, which you can go on and do some reducing. 75 out of 100 gives you 3/4. Yeah, so which you can write it as 3/4 or 0.75. Members, is that fine? Members, let me know. Are we together on that? Yeah. Okay. Okay, it seems we're on the same page. Then the second one, both prime and are factors of 100. So both prime and are factors of 100. So when you look at my diagram, that one you're going to do it on your own. They are prime and factors of 100. So now diagram, this is the set here. So, and you know how many members you have there. So that one, you can do it. You can do it. You can do it. 0.02 according to Jonah. Thank you. 2 out of 100, Victoria. Okay. Okay. And then, so when you have 2 out of 100, that is very okay. 0.02, very fine. Then the last one, a factor of 100, but not prime. Now, there you go back to your diagram. It is a factor of 100. But it is not applying. So factors of 100 are that factor, the whole of this set, is the factors of 100. But when you look at 2, 2 has an element of prime. So meaning that factors of 100 we shall only shade here. These are what we call the factors of 100 but are not prime. Factors of 100 that are not prime. So we shall shade there, and we shall have how many elements there? 7 out of 100. That is Imi, Jonah. Okay. I think we are on the same page. We are on the same page. Good. Okay. I think so here I expect you to have 7 out of 100. Okay. Hope members, we are good. We are good. So let me check whether I have 1. Okay. I'm giving you some activity now to do. This is going to be your activity to do. You remember our coins, so this is going to be your activity to do. Yeah, you can take a screenshot. You can take a screenshot. You can take a screenshot. Okay, hope members have finished. I want to do one last one, and this is going to be our last one. Then the rest are going to be yours to try out. So they are telling us that a 2-digit number is formed using the digits 4, 6, and 7 without repeating any digit in the number formed. Write down the possibility space for the numbers formed. Now, what does it mean? Aha. Now, I'm going to ask you, feel free to type in the chat. We have three what? 3 numbers that have been given: 4, 6, and 7. So just type in okay, you can raise up your hand and you tell us the numbers you can see being formed. Like when they talk about a number in math, like when you have 1, 2, 3, 4, 5, 6, 7, 8, 9, these ones we call them digits. That single thing is just called a digit. But when you combine in 2 digits, 1 and 5, this one is what we call a number. So I start with the Desire.
Okay, so we can form 4, 6.
Okay, wait. We can form
4, 6.
46. You tell us the number.
6. We can form 47.
47.
We can form 67.
67.
74.
74.
64.
64.
76.
76.
We can form 67.
Already?
Okay. I think that's all.
Okay, thank you. Okay, I'm not seeing any hand up. It seems that you have exhausted all the numbers. Yes, so looking through the chat, those are the numbers that we have formed. So here I can cross. But now I want you to let you know that what you always do, in case they give you 3 numbers like this, what you do, first fix one number. Let me say 4. Fix it. Then rotate the other one. Have the 6, 7, rotate the 7 and the 6. Still on 4. Go to the next one. Start with 6. Now you have 2 other numbers. You have the 4 and 7. Fix 6, let it be constant, rotate the other 2. Go to the next one, which is 7. Have the other 2 numbers you have not dealt with, then shift them, but when one is constant. Something like that. But this one, I'm telling you, this is when you have three numbers. This is when you have three numbers. But still, the same thing applies when you have two. When you have two, first fix 4, then bring. That one can be 6. This is 4, it can be 7. Go to the next one, 6. Bring what you have not said. This is 4, still 6, bring the 7. This is which one? It is 7, bring the 4, the 7, fix it, bring the other one. Hope members, that is very okay. So that's what you call a possibility space. So sometimes they can even ask you, form a 3-digit number. Then they ask you, find a probability that the number formed is an even number. Now here, I want you to go and revisit your work of senior 1. You need to know what you call an even number, odd number, prime number, triangular number, because they can ask you from any of those angles. So you need to be very, very informed about them such that you do not mess up. So that one, at least make sure you know them very well. Those 3-digit number, whether applying, so you need to know because when you don't know them, it means that you will not be in position to generate you're not going to be in position to generate the events corresponding to what they have asked you. Meaning that chances are high you'll be failing to get your answer. Okay, now they told us an even number. So who can list for us even numbers? But Vicky?
So the even numbers we have here are 46.
Event of even numbers. You have said there are 40, we have 46.
We have 74.
We have 74.
64 and 76.
64 and 76. Can you tell us briefly about those numbers? About even numbers, just okay. What you know about them? Something special, okay, maybe something like that.
They can be divided by 2.
They can be divided by 2. Okay, so looking through the numbers they have given us, the number of elements within the event, I'm not seeing there 4. So meaning that our probability that we shall get an even number will be the event divided by the sample space. So here we shall have our 4 divided by the numbers, which are 6. So when you reduce, you can be able to get. So when I reduce 4 by 6, I can say by 2, then the other one is 3. Then I write it like that. So here I can write 2 out of 3. Then when they ask more than 65, so I don't know which set you have within 65, you look through your numbers, choose those numbers you notice that are more than 65. So more than 65, this is one of them. I have this one and then this one. So here, I expect you to write your probability as 3 out of 6, which you can reduce to a half. Members, may I know whether we are on the same page, whether there is someone who is lost? Okay. Same page. Okay, it seems people are on the same, yeah. Yeah, it looks good now. It seems we are on the same page. Okay, since we're on the same page. Okay, same page. Okay. I'm going to ask you now. Oh, this is your exercise. Like I told you yesterday, this week we shall be finishing a bit early. In fact, for the rest of this January, unless I get, but I'm still sorting out something. I told you I have some engagements at around 8, so I have to travel a bit early. So we shall end here. Okay, hope people have taken a screenshot. Let me know whether you have. Okay. Then someone has asked me to go back to The other slide, this slide, I think, for the activity. Okay. Okay. I'm seeing a hand. Yes, Desire. Those who have questions, maybe you can ask now.
Could you please put back the previous slide you've been working? The one of the sample spaces.
This
Yeah, that
one?
one. Yes.
Okay. Hey, sorry. Hope you had finished.
Yeah, I had.
Okay. 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 Then for this one, let me hope members have finished. In fact, even you are not saying, you need to know what a vowel is, what a consonant is. Yeah, so you need that kind of knowledge with you to be very, very safe. So you'll try out those different activities I've left for you. Yes. And then we shall start from there when we meet again. Okay, I wish you a good day and bye-bye, everyone. See you in the afternoon, and let me hope members are completing some work that was left yesterday. Yesterday we left some work. Let me hope we are completing.
So can you send it now?
The what?
The work of yesterday for composite functions.
To send worked examples.
No, like I've done the activity.